Your review covers sections 2.4 to 2.8 that are on your test. The first section that we're going to look at is average rate of change. Remember, average rate of change is just your slope formula. So y2 minus y1 over x2 minus x1. If you look at number 1, it's telling you between x is equal to -4 and x is equal to 0. So where x is at -4, that's the ordered pair -4, 0. Where x is 0, that's the ordered pair 0, 1. So we're going to find the rate of change between these. So we have 4, or -4, 0, and 0, 1. Okay, so we're going to do y2 minus y1 over x2 minus x1. So that's just going to give us 1 minus 0 over 0 minus -4. The 1 minus 0 is just 1. Double negatives turn into positives. 0 plus 4 is 4. That's 1/4. For your next one, you are going between x is equal to -2 and x is equal to +2. Your x is equal to -2 is the ordered pair -2, 0. Your x is equal to 2 is the ordered pair 2, 2. So this is -2, 0, and 2, 2. So again, we're using y2 minus y1 over x2 minus x1. That's going to give us 2 minus 0 over 2 minus -2. Double negatives turn to positives. That's going to have 2 over 4, which is just 1/2. For 3, we're going between -3 and 4. At -3, you are at the point -3, 3. At 4, you are at the point 4, -3. So we have the ordered pairs -3, 3, and 4, -3. So again, we're going to be using y2 minus y1 over x2 minus x1. This is going to give us -3 minus 3 over 4 minus -3. Again, double negatives turn to positives. Up top, you're going to have -6. Over on the bottom, that's 7. So it's just -6 over 7. I don't think it's in your review, but remember, if it asks you for the net change, it's just your y2 minus y1. You know which ordered pairs are your x1, y1, and your y2, or x2, y2, because the one that's on the left in your coordinate plane is your x2, y2. The one that's on the right is your x1, y1. For the next section, you are finding whether the function is odd, even, or neither algebraically. Remember, with these, you can either plug in the negative x and see if you get the same thing, or do what I do, 2 and -2. If you get the same numbers, they're even. If you get opposite numbers, they're odd. And then if you get 2 totally different numbers, it's neither. So for number 4, we have f of x is equal to 6x cubed minus 5 over 2x squared plus 7. You're going to do f of 2. Let me change the color here. F of 2 is going to give you 6 times 2 cubed minus 5 over 2 times 2 squared plus 7. And then you're also going to find f of -2. So that's going to be 6 times -2 cubed minus 5 over 2 times -2 squared plus 7. For the one on the left here, that 2 cubed is 8, so that's 6 times 8 minus 5 over 2 times 2 squared is 4 plus 7. Your 6 times 8 is 48 minus 5 over 2 times 4 is 8 plus 7. So this is going to give us 48 minus 5 is 43 over 8 plus 7 is 15. So that's f of 2. For f of -2, we have -2 cubed, which is -8. So 6 times -8 minus 5 over 2 times -2 squared is 4 plus 7. That 6 times -8 is -48 minus 5 over 8 plus 7 is going to give us -53 over 15. So that's f of -2. These two numbers are two totally different numbers. They are not the same. They are not opposites. So this one is neither. For number 5, we are working with g of x is equal to x cubed plus 2x to the 4th power minus x squared. To find g of 2, we're going to do 2 cubed plus 2 times 2 to the 4th power minus 2 squared. The 2 cubed is 8, plus 2 times 2 to the 4th power is 2 times 16, minus 2 squared is 4. Your 2 times 16 is 32, so that's 8 plus 32 minus 4. Your 8 plus 32 is 40, minus 4 gives you g of 2 is equal to 36. Next, find g of negative 2. Your g of negative 2 is going to be negative 2 cubed plus 2 times negative 2 to the 4th power. Oops. Minus negative 2, not 4, minus 2. Negative 2 to the 4th power minus negative 2 squared. That negative 2 cubed is negative 8. The negative 4 squared is 16. And that negative 2 squared is 4. So this is going to give us negative 8 plus 32 minus 4, which is negative 8 plus 32 is 24, minus 4 gives us g of negative 2 is equal to 20. Once again, these two numbers are totally opposite or totally different numbers, so this one is neither as well. For your next set of questions, you are describing the transformations. For number 6, we're given h of x is equal to negative 4 square root x plus 7 minus 9. The negative that is in front of that 4, it's a reflection vertically, so up and down, so it goes across your x-axis. So you can put down that it reflects across x-axis. Next, you have the 4. That's in front of the square root. That 4 is greater than 1. It stays as that 4. We have a vertical stretch by a factor of 4. Next, we have that plus 7 on the inside. Think opposite of it. Since it's on the inside, we're going to the left 7 units. And lastly, that minus 9 is on the outside, so we're going down 9. For number 7, we have h of x is equal to the absolute value of negative 5x plus 8 plus 1. The negative that's in front of the 5 reflects horizontally, so it goes across your y-axis. Next, you have the 5 in front of x on the inside. That 5 you need to take the reciprocal of. It is 1/5. That 1/5 is less than 1, so we are horizontally shrinking by a factor of 1/5. Next, you have that positive 8, so we're going to the left 8 units. And then we have that plus 1, which means we're going up 1 unit. For your next part, you have f of x is equal to 3 minus x squared. G of x is equal to 1 over x squared minus 4, and h of x is equal to 4x plus 7. For number 8, you are finding f plus g of x. So if we take f of x plus g of x, we are going to have 3 minus x squared plus 1 over x squared minus 4. In order for you to have or be able to add these, you need like denominators. So you're going to put this 3 minus x squared over 1 and multiply top and bottom by x squared minus 4. Oops. FOIL on the top. That's going to give you 3x squared minus x to the 4th power minus 12 plus 4x squared all over x squared minus 4 plus 1 over x squared minus 4. They're both over the x squared minus 4, so you can just combine your numerators, put it in standard form up top. That's going to give you negative x to the 4th power. You have 3x squared plus 4x squared, which is 7x squared. Then negative 12 plus 1 is negative 11, all over x squared minus 4. Your domain for this one comes from your denominator of your fraction. So yes, this is your answer, but your domain comes from that x squared minus 4. If we set that not equal to 0 and solve, you get that x can't equal plus or minus 2. So your domain goes from negative infinity to negative 2, parentheses, with a union of negative 2 to 2, parentheses, with a union from 2 to infinity. For number 9, you have g times h of x. So you're going to take g of x and multiply it by h of x. So that means you are going to have 1 over x squared minus 4 times h of x, which we said was 4x plus 7, and that's over 1. You can multiply this straight across, and that's just going to give you 4x plus 7 over x squared minus 4. Again, your domain comes from your denominator. We had the same thing in the one before this, so your x can't equal plus or minus 2, which means your domain goes from negative infinity to negative 2, with a union from negative 2 to positive 2, with a union from 2 to infinity. For number 10, you're doing f divided by g of x. So f of x, we said, is the 3 minus x squared. So f of x divided by g of x, you're going to have 3 minus x squared over 1 divided by g of x, which we said was 1 over x squared minus 4. So with this, before you do anything, you don't really have to state what your x doesn't equal, because you're going to get rid of the x in the denominator. So you're going to keep, change, and flip. So you have 3 minus x squared over 1 times x squared minus 4 over 1. And then you're just going to multiply or FOIL it out. So 3 times x squared is 3x squared. 3 times negative 4 is negative 12. The negative x squared times x squared is negative x to the 4th power. And the negative x squared times negative 4 is positive 4x squared. So I'm just going to rewrite this in standard form. And that gives us negative x squared plus negative x to the 4th power plus 7x squared minus 12. So that's your division part. Your domain of this, again, you could give the x squared minus 4 is not equal to 0. So it would be the same thing as the ones before this. So you're going to go from negative infinity to negative 2 with a union from negative 2 to positive 2 with a union from 2 to infinity. 11 asks us to find g over h of x. So again, we're doing g of x divided by h of x. So we said g of x is 1 over x squared minus 4. The h of x was 4x plus 7. So we're going to put that over 1. So once again, you have an x squared minus 4 in the denominator. Your domain, automatically, negative infinity to negative 2, with a union from negative 2 to 2, with a union from 2 to infinity, because you had that x squared minus 4 in the denominator. If you had a 2 in there or a negative 2 in there, it would give you 0 in the denominator. You can't divide by an undefined fraction. So from here, we are going to keep, change, and flip. So you're going to have 1 over x squared minus 4 times 1 over 4x plus 7. Multiply these out. You also have a 4x plus 7 in this denominator, so guess what? Can't have 0 in that either, so x can also not equal the negative 7 over 4. So keep that in mind when you're working with your domain later on. Multiply these out. This is going to give you 1 over 4x cubed plus 7x squared minus 16x minus 28. So this is your division part. With your domain, we have that x can equal negative 2, x can't equal the negative 7/4, and x can't equal 2. So that's all 3 of them. The smallest one that you have here is the negative 2, then the negative 7/4, then the 2. So you're going for your domain from negative infinity up to negative 2 with a union from negative 2 to negative 7/4 with a union from negative 7/4 to 2 with a union from 2 to infinity. So that whole thing is your domain. For our next page, we have f of x is equal to 4x minus 2, g of x is equal to 5 minus x squared, and h of x is equal to 3x minus 1. For number 12, we are finding f of g of x, which means take g of x, plug it in for x and f of x. So f of g of x. We said g of x is 5 minus x squared, so that's technically saying find f of 5 minus x squared. So we're going to plug that 5 minus x squared in for x in the 4x minus 2. So that's going to give us 4 times 5 minus x squared minus 2. You don't have a fraction, so your domain is going to be all real numbers for this one. Distribute your 4 in. This is going to give you 20 minus 4x squared minus 2. Combine your like terms here. 20 minus 2 gives you 18. So that's negative 4x squared plus 18. And again, we said our domain is all real numbers. So from negative infinity to positive infinity. So 13, we have h of f of x. This is the same thing as saying take f of x, plug it in for x in h of x. So technically we're doing h of whatever f of x is, which is 4x minus 2. So take the 4x minus 2, plug it in for x in 3x minus 1. That's going to give us 3 times 4x minus 2 minus 1. Then simplify. 3 times 4x is 12x. 3 times negative 2 is negative 6. Subtract the 1 with the negative 6. That gives you 12x minus 7. Your domain, all real numbers. No fractions, no radicals. So from negative infinity to positive infinity. For 14, you have 1 times g of h of x. So you're going to take g of x, h of x, plug it in for x in g of x, then multiply it by 1. That's all it is. So this one, h of x is the 3x minus 1. G of x is 5 minus x squared. So you're doing g, or 1, times g of 3x minus 1. The g of 3x minus 1, take 3x minus 1, plug it in for x in g of x. So that's 1 times 5 minus 3x minus 1 squared. The 3x minus 1 squared, rewrite it as 3x minus 1 times 3x minus 1, and then FOIL it out. This is going to give you 1 times 5 minus 9x squared minus 6x plus 1. Distribute the negative into the 9x squared minus 6x plus 1. So you have 1 times 5 minus 9x squared plus 6x minus 1. Combine like terms on the inside. Your 5 minus 1 is 4. So that's 1 times negative 9x squared plus 6x plus 4. Multiply it by the 1, and that's just negative 9x squared plus 6x plus 4. Once again, there's no fractions or radicals in any of this, so your domain is just from negative infinity to positive infinity. For 15, you have g of f of negative 2. So first find f of negative 2, then plug that in for g of x. We said that f of x is 4x minus 2, so that's going to be 4 times negative 2 minus 2. That is going to give us negative 8 minus 2, which is negative 10. So we're finding g of negative 10. We said g of x was 5 minus x squared. So that's going to give us 5 minus negative 10 squared, which is 5 minus 100. And that's negative 95. For 16, you have h of g of 3. We said g of x was 5 minus x squared. So g of 3 is going to be 5 minus 3 squared. Your 3 squared is 9. 5 minus 9 gives us negative 4. So we're finding h of negative 4. That h of x, we said, is 3x minus 1. So that's going to give us 3 times negative 4 minus 1, which is negative 12 minus 1, and that's negative 13. For 17, we have f of g of h of 1. So the first thing we're going to find is h of 1. We said h of x is going to be 3x minus 1, so that's 3 times 1 minus 1. 3 times 1 is 3, minus 1 is 2. So next we'll find g of 2. G of x was where was it? 5 minus x squared. So that's going to give us 5 minus 2 squared, which is 5 minus 4, which is 1. So now we find f of 1. F of 1 was the 4x minus 2. So that's going to be 4 times 1 minus 2, which is just 4 minus 2, which is 2. For your last three, you're finding the inverse algebraically. For 18, you're given f of x is equal to 7x squared plus 6. So we're going to change the f of x to be y is equal to 7x squared plus 6. Then you're going to switch x and y to give you x is equal to 7y squared plus 6. Now you're going to solve for y. So subtract your 6 over. You have 7y squared is equal to x minus 6. Divide each side by the 7. You have y squared is equal to x minus 6 over 7. From here, you're going to take the square root of both sides. So y is equal to the square root of x minus 6 over the square root of 7. Can't leave the square root of 7 in the denominator, so multiply top and bottom by the square root of 7. This is going to give us y, or f to the negative 1 of x, is equal to the square root of 7 times x minus 6 all over 7. No, you don't have to worry about the plus or minus on this one. For 19, you have g of x is equal to 7 minus 5x squared over 4. For this one, again, that's y is equal to 7 minus 5x squared over 4. Change your x or switch an x, y. So x is equal to 7 minus 5y squared over 4. Multiply each side by the 4. This is going to give you 4x is equal to 7 minus 5y squared. Move your 7 over, subtract it from both sides. You have negative 5y squared is equal to 4x minus 7. Divide each side by the negative 5. You have y squared is equal to 4x minus 7 over negative 5. Take the square root of both sides. That's y is equal to the square root of 4x minus 7 over the square root of negative 5. From here, can't leave the negative under the radical, so you can take that out by representing it with I. You're going to multiply top and bottom by the square root of 5. Let's do the square root of negative 5. Well, yeah, let's do the square root of negative 5 instead of doing the I. So multiply top and bottom by the square root of negative 5. This is going to give you y, or f to the negative 1 of x is equal to the square root of negative 5 times 4x minus 7 all over negative 5. If you want to turn that negative 5 into a positive and pull that negative out front of your radical, you can do that too. And then for your last one, you have h of x is equal to 6 plus the square root of 2x plus, 2 plus x. So this one, you're going to have y is equal to 6 plus the square root of 2 plus x. You are going to change that y and that x to just switch places. So it's x is equal to 6 plus the square root of 2 plus y. From here, move your 6 over. You have the square root of 2 plus y is equal to x minus 6. You're going to square both sides to get 2 plus y is equal to x squared minus 12x plus 36. Then subtract your 2 over and rewrite this as f to the negative 1 of x is equal to x squared minus 12x plus 34. Remember, with these inverses, you have to put the f to the negative 1 of x.